Okay, grade 12. Let's look at what we have on this question. And this is 5 marks. They say that a grade 12 learner with a mass of 75 kg is on a skateboard with a mass of 2 kg, which is moving at a constant velocity of 2 meters per second east. So now, a ball mass of 500 gram that is moving at a speed of v meters per second is going to the west. So this is thrown at the learner. So the learner catches the ball. Then we're also given the kinetic energy after this collision. So guys, first thing first, they want us to calculate the initial speed of the ball. So the formula that we're going to use for this problem is the momentum before the change in momentum. Let's call this the change in P before. It's equals to the change in P after. Please, I'm going to take you step by step. So now, once you first start by writing this formula, then you're going to know what you need and what you have. So now look at this. The change in P before is going to be the mass of the learner. Let's call the mass of the learner. So this will be ml. We need to multiply that by the V initial of the learner. Let's call this VL initial. Right, I hope this makes sense. Then this is for the learner, is the mass times the velocity of the learner. This is initial. Then we also have to add this because before, remember, this is before, the change in momentum before. So we're going to add this with the mass of the ball. Let's call this MB. Therefore, which needs to be multiplied by the V what? The V of the velocity of the ball, and this is the initial velocity. We equate this to what? So now what I need you to understand is that after momentum, after the collision, can you see that the learner is going to catch the ball? So when the learner is going to catch the ball, they will move at the same velocity. So the learner, the skateball, and the ball, they will all move at the same velocity. So this tells you that you'll have to add all these three mass. I hope this makes sense. So we're going to say, let's call this the mass of the learner. But remember, the mass of the learner goes with the skateboard. Né? So this will be the mass of the learner. We need to add that with the mass of the ball. Then now, all this, they will move with one velocity. Let's call this V final. What are they looking for? Look at this. They are looking for the initial velocity of the ball. So we are looking for this guy. Right. So now check. Can we get this? Can we get the mass of the learner? Yes. Can we get the V initial, the initial velocity of the learner? Can we get that? The initial velocity of the learner was given. So now, the only thing that we need here, the only thing that we are looking for, they want us to find the initial velocity of the ball. Do we have the final velocity of this? No, we don't have the final velocity. Right, let me do the substitution first so that this can make sense. What is the mass of the learner? It's 75 kg. So the 75 kg, we need to add that with the skateboard, which is 2, and then multiply this by the V initial of the ball and of the boy. Remember, this guy is moving at 2 meters per second. So this will be 2 plus the mass of the ball. So please make sure that when the mass is given in grams, you convert this by dividing that by 1000, which will give us 0.5. So this will be 0.5 times the V initial, which is what we are looking for, the velocity of the ball. Right. This is equals to, now look at this. The mass of the learner, we know that is going to be, this is after, is going to be 75 plus 2 plus 0.5 after, so because they will move at one velocity. So this is going to be 77.5 plus the mass of the okay, we already added everything now. We already added all three subjects, so this will be 75.5. I hope this is the best approach that we are using now. I don't want you guys to be confused on this easy problem and V final. So now we have two unknowns. So now look at this. They said that the learner catches the ball and the kinetic energy after this collision is 146 joules. What is the formula for kinetic energy? So now we can say EK after, let's say EK after, it's equals to 1 over 2 mv squared. This is the formula for EK, but now the EK is given as 146 joules. So this will be 146, it's equals to 1 over 2. The mass, remember they will move at the same, all of them, they will move with one velocity. So we need to use this mass. We need to add all these three objects. So this will be 77.5. And we are looking for what? We are looking for that v squared, because this is the final velocity that the boy and the skateboard and also the ball will move at. So that's the velocity that you are looking for. So when you have it like this, we can just say 1 over 2, what is 77.5 divided by 2? We get this to be 38.75. So this is 146, it's equals to 38.75 v squared. Divide both sides by 38.75 divided by 38.75. This is equals to, I'm going to say 146 divided by answer. This gives us 3.76, né? 3.77, which is equal to v squared. So what is the square root of that? Gives us 1.94. So when you square both sides, you'll have your v to be 1.94 meters per second. So now we have this v, now the final velocity after the collision. We can just go back and substitute and solve for the velocity of the ball, the initial velocity of the ball. I hope this makes sense, né? So we just have to work out this part and also substitute that. So what is 75? This is going to be 75 plus 2 times 2. So this is 154. 154. Then we still have plus 0.5 multiplied by v of the ball initial. And this is equals to the 77.5, which is multiplied by that v of 1.94. So this is multiplied by 1.94. So now we can say the 0.5 of VB initial, it's equals to, this will be 7.5 into 1.94. Let's bring this 154 this side to be negative. So this will be negative 154. Okay, so now I'm going to have the 0.5 of the VB initial. It's equals to, let's punch that on the calculator. Please make sure that you punch this correctly on the calculator. So this is times 1.94. Then we're going to minus 154. 154. This gives us negative 3.65. Okay, so divide both sides by 0.5, divide both sides by 0.5. Therefore, what is the velocity of the ball, the initial velocity of the ball? So we take this, we divide by 0.5. This gives us negative 7.3 meters per second. So why is this giving us negative? Because this tells us that east was taken as positive on our calculations. We forgot to choose direction. But now, for the fact that we substituted these two as positive, so this tells you that we took east as positive. So now the velocity of the ball, remember the velocity of the ball is going to the west. So therefore we can say the VB initial, it's equals to 7.3 meters per second. And where is this going? To the west. Right, and that's how we answer this problem. I just hope the approach, we used the best approach, because I tried by all means for you guys to understand why are we adding, where is the 77.5 coming from. After the collision, all these three guys, this guy will hold the ball, so we need to add this mass and that mass and that mass, because they will all move together. Then to find the V final after the collision, we used the final kinetic energy of 1.46. So what you have to know is the formula that you need to use to find the formula for the final kinetic energy. That's the formula. EK is equal to 1 over 2 mv squared. Since this is final, we use the mass of all these three subjects, all these three objects. I hope everyone understand how we solve this problem, and that's it for this lesson.